G'day guys, this is Mr. McBain and I'm now going to do a series of programs on electricity and electric circuits. So our first program we're going to talk about three of the really important aspects of electric circuits, and that is the idea of current, voltage and resistance. So we'll start off with current. Okay, so what I have here is a piece of wire. This wire could be made out of copper, it could have been made out of iron or silver. Most metals will conduct electricity or allow electricity to flow through it. Now what that really means is that the electrons inside that metal are sort of free to move. They float around in the metal. And if we apply an electric charge to one end, a positive charge at this end, for example, and a negative charge at the other end of our wire, we know that positive will repel positive and attract negative. So these negative electrons here will all want to flow in that direction because they'll be attracted to the positive and repelled from the negative polarity. And if we were able to count, if we set up a little line there and we counted the number of electrons that pass that line in 1 second, that would be a measure of current. So current is a measure of the amount of charge that flows past a certain point in a given amount of time, which is usually 1 second. So it's the amount of charge that flows past a given point in 1 second. Now, if we were actually counting individual electrons, the numbers we'd be dealing with would be astronomical. There would be trillions upon trillions upon trillions of electrons passing that line in 1 second. And so we come up with a more convenient way of counting electrons, and that is the Coulomb. Now, if you've done chemistry at Year 10 level, you've probably heard of the Coulomb. 1 Coulomb is actually a measure of charge. 1 Coulomb is equal to 6.25 times 10 to the power of 18 electrons. So if you can imagine that many electrons packed up into a little sack or a parcel, that parcel would represent 1 Coulomb of charge. So Coulomb is a measure of charge. Now, getting back to current, because current is a measure of how much charge passes a certain point in a given second, we actually measure current in coulombs per second. So current is measured in coulombs per second, otherwise known as the amp. So 1 amp, or 1 amp is actually short for ampere, but 1 amp of current means that 1 Coulomb of charge is passing this point every second. 1 Coulomb per second. So that means if we measured the current through this piece of wire and found it to be, for example, 4 amps, that would mean that 4 times 6.25 times 10 to the power of 18 electrons are passing that point every second. So that's the idea of current. And there's a little backstory that goes with this. When we actually connect wires to batteries and electric sources to create circuits, there can either be positive people thought in the past that it could either be positive charges or negative charges moving. Now, until we understood the nature of the atom, it was pretty much a guess. And everyone guessed that it was the positive charges that were actually moving in the metal. This was hundreds of years ago. But of course, they were wrong. It's not the positive charges that move, it's the electrons. The positive charges are actually locked into the structure of the metal. They form part of the nucleus of the atoms, which do not move. What does move are the electrons, which are free to move from atom to atom. So in any electric circuit, it's actually the electrons that move. The electrons move through the wire. But because so many people, so many scientists believed that it was the positive charges, that idea stuck. And this causes a little bit of confusion nowadays, because when people now talk about current, when we talk about the idea of current, we're talking about, or the direction of current I should say, we talk about the way that a positive charge should move. So if we're looking at this circuit in this diagram here, if we had to talk about the direction of the current, well, that direction would be the direction that we'd think the positive charge would move, and the positive charge would move to the right. So that is what we call the direction of current. That is the current direction. It's the direction that positive charges would want to move. But we know, in fact, we actually know that it's actually the electrons that are moving. The electrons are actually moving in this direction. And we call that the direction of electron flow. So there's two directions to be aware of. The direction that positive charges would move, which is a hangover from a historical past and confusion back then, and the idea of electron flow, which is the way the actual electrons are moving. Now, if you work out the current in a calculation and you find it to be, say, 4 amps, so if you calculate the current to be 4 amps and the direction of current is in that direction, then it's very, very safe to assume there would actually be 4 amps of electrons moving in the opposite direction. So in terms of calculations, these signs don't have any effect on any calculations. We just need to be aware that the direction that the electrons are moving is the opposite direction to the direction of current. Okay, so you need to be aware of that difference. Okay, so that's our little section on current. In the next page, we'll talk about voltage.